Hello, Ms. Burton. Now we're going to be talking about parallel lines. Today, here, I'm going to show you how to write an equation of a line that is parallel to a given line. I'm going to show you some examples, and together, we're going to dissect this topic. Let's go. Lines are parallel if they lie in the same plane and are the same distance apart over their entire length. And parallel lines remain the same distance apart over their entire length. No matter how far you extend them, they will never meet. This problem is fairly easy because I got taught in 5th grade that if you look at a railroad, the two metal sides of the railroad track are all never going to touch. They're always going to be side by side and go on, because if they touch, then the train wouldn't be able to move. And that's how I always remembered it, and that's how this problem is always easy to me. They will go on and on forever until something blocks their path, but nothing's going to. So these all examples are parallel lines. Alright, let's do this as an example. We're going to find the parallel line of this equation. And this line contains the point 3, 5. You always need the point whenever you do parallel and perpendicular lines. Alright, so we got our two basic informations. Alright, to find the slope of the parallel line, all you have to do is look at the 2x. Boom. Right there. That's the slope of our parallel line, the one we're going to make. Because the parallel line slope is always the exact same as, the basic equation slope. So whatever parallel line you have to find from an equation, like any equation, the slope is always going to be the same. But we have to turn this into y equals mx plus b, or the slope-intercept form. So we're going to move this y over here. We're going to move the equal sign with it. We're going to take the 2x, move it over here, but since it crosses the equal sign, it's going to be negative 2x. And then it's going to be plus 3. Now, that's a slope-intercept form, but we have this negative y here. We can't do that. So we're going to multiply each side by negative 1. And what we end up with is y equals 2x plus 3. You don't touch the b. You don't touch b. And there you go. That is this in slope-intercept form. Now we can get to work doing our parallel line. We have to now, for step 2, use the point-slope form for the equation of this line. So we're going to have y minus y1 equals m times x minus x1. But since we have 3 and 5, we are going to have y minus 5 equals, let's make that better. Equals 2, because remember the parallel line slope is exactly the same, x minus 3. And that's that in point slope form. And that's your answer. Y minus 5 equals 2, x minus 3. Hooray, good job. Now, let's take this problem a step forward, even more. We now have our answer in point slope form. This is the parallel line. But now let's expand our knowledge and make it put it into slope-intercept form. Now we're going to have our original equation, y equals 2x plus 3, and now the parallel line to it. First, you're going to have to multiply 2 by x and by 3. The left side doesn't get touched. So what we're going to have is y minus 5 equals 2x minus 6. Now, let's put this into slope-intercept form. Add 5 to each side. We end up with y equals 2x minus 1. And there you go. That is the answer. That is our parallel line to y equals 2x plus 3 in slope-intercept form. Hope you liked this tutorial, Ms. Burton. Stay tuned.